This episode was originally recorded on Patreon. For access to one new video each month, nearly a year before anybody else, check the description below. Welcome back to another Patreon episode, and I've recently been playing Pokemon Radical Red. If you don't know, it's Fire Red, really scaled up to be really difficult. It's really hard. And I was thinking about some of the gym puzzles and thought, could I recreate these on Construct? I thought that might be a fun video to do where I recreate 8 different gym puzzles. And I think what it's going to do is not just recreate some Pokemon levels, but actually give us 8 different tile-based puzzles. Because I feel like when we look at puzzles, there's not many based around the tile-based movement. So let's have a go. Starting with Gym 1 then, I want Gym 1 to be a maze. Not just a normal maze though, a typical Pokemon maze where you're in the dark. So how do we approach this problem? Well, first thing that we need is we're going to go to layer 0, we're going to insert above, and we're going to create layer 1, and this is going to be our dark screen. I'm going to click here, set the appearance from transparent, and just tick that off. I'm going to fill this in black. Now, we might want it to not be completely pitch black, so we can drop the opacity. Let's drop it down to, say, 90%. Now what we need is some sort of spotlight, so some sort of circle around the player so we can see in our general area, but we can't see much further than that. So for this, we're going to insert a new object, scroll down to Sprite, and we'll call this Spotlight. Now for this, what we're going to do is we're going to grab the paintbrush, we'll set the color to white, and we want it to be a decent size. Let's make it a little bit bigger. We can change this in the editor. Not that big. We'll go for that. We're also going to drop the hardness down a bit. This means that it will be brighter in the center and not as bright on the edges. So get that into position that we want. We'll drop the opacity down a little bit as well. Click, crop the edges, and then press X. Now we've got the spotlight, we're going to just place it out of the way because we don't necessarily need it on the screen. We do need to add a behavior to it though, and that is going to be the pin behavior, because we want this to be attached to our player. Now if we go into the event sheet, we're going to add one event, and it's just going to be a system event. Scroll down to on start of layout. We're going to take our spotlight. Now the first thing I'm going to do is just set the position to player X and player Y. You don't normally need to do this when using the pin because it should attach already. Recent Construct updates, I've had some issues with this, so I just like adding that extra sort of safety net. But we're going to take our spotlight, scroll down, pin to object, and we're going to select our player. So that's nearly all the steps done. Last one that we just need to do is just go to our blend mode, and we're going to do destination out. Hold it over and you can see that we get this sort of light up effect. Press play, and now as we move we can see just in the area around us, but it's a bit hard to see the edges. So let's quickly construct a maze. So here's our final maze. You can see that I've dropped the opacity down even more, so now it's almost impossible to see any other part of the maze. This makes it very difficult to try and solve, and we're going to hit a lot of dead ends. Now a couple of things we can do is we can make the light bigger if we can't see. We can also sort of drop the opacity a little bit more. This means we can see some of the bits. This is really good if you're making a nighttime level, but eventually we'll find the correct path to get to the end square. If you've made a game in Construct, I want to see it. The summer showcase is nearly upon us, so check the link in description on how you can have your game shown in the showcase. Right, moving on to Gym 2 then. I thought an ice puzzle is quite a common one that we see inside of Pokemon games. Might be a fun one to try and recreate. So first thing I've got ice. This is just a tile background, so I can just make this any size I want. I'm also using the grid sort of option here to snap to grid. This is really nice when designing stuff that's tile based. So with these tile puzzles, if you're on the ice, you'll keep moving in the direction that you're moving in already until you hit a wall or you come off the ice. So let's go to the event sheet for this. Event sheet for this is actually not too bad. We're going to add an event, and we're just going to do a check to see if the player is on ice. So is overlap another object being ice. We're then going to add another condition onto our player, scroll down, and with the tile movement we've got this one called is moving in direction, and we can check the different directions. So we'll start with up first. And nice and simple, all we're going to do is, if they're on the ice and they were moving up, we're going to keep that going. So the way we do that is just go down and simulate control of up. We're now going to repeat this for our 4 directions. So I'm going to copy this 4 times, and it's just a case of going through and changing it for each of the different directions to get our 4 different tile movements working. Now this is nearly complete, however we can still move ourselves, so when we're on the ice we can decide to change the direction of any of these. So what we need is just some more events, and we're just going to say if the player is overlapping another object, being our ice, then what we're going to do is we're just going to take our player, scroll down, and we're going to set default controls to false. So now they can't move. Obviously, when we come off the ice, we want to be able to move again. So we're just going to copy and paste this command, and we're just going to change this to invert, and change this to true. So now if you're no longer on the ice, you can move. The only final problem that we've got is what happens if our player is at an edge here. So they've reached the edge, they've hit a wall, they can't move anymore. However, our code still says they're on the ice. So for this nice easy fix, we're going to just right click here and add an OR block. Right click to add a new condition, go to player, scroll down, and we've got the option of is moving, and we can just invert this once again. So now we can say if they're not on ice or they're not moving, so that's true. And because this happens after this line of code, this one always takes priority. So even though we're on ice, this code will trigger after and say, actually, no, you can move now. So let's do a test. I'll walk on the ice. I can't press anything else until I reach the wall at the end. Once I come off the ice, I can move again. Again, I'm stuck here. I can move in any direction. I can come off. So let's design gym number 2. So welcome to gym number 2, the ice gym. So for this, we need to navigate the ice puzzle in order to reach the end. Again, this is one that you can expand and make far more complex than I have here. But that's my simple take on this puzzle. Moving on to Gym 3, I thought we'll do something with conveyor belts or arrows. This is something that's a lot in Gen 1. You go on the arrow, you get pushed in that direction, and you can have multiple arrows put in place. So for instance, we can create a little bit of a conveyor belt track by just moving some of these arrows about. And again, the player will be locked into this conveyor belt until they reach the end of the course, and then they can go on to another conveyor belt. And again, this is a bit of a problem they have to try and solve of what is the best path to go on to get to the end goal. So if I put in my final ones like that, whatever part of this conveyor belt we go on will be always finishing in this spot where my mouse is. So how do we put this together? Well, first thing, these are just a sprites. I've called it arrow. And again, I've started by just facing the sprite upwards. So moving on to the event sheet, this is very similar to our ice puzzle, so I decided to do this one next. So we're going to start by adding an event onto our player. We're just going to check if it's overlapping another object, and this time we're going to select our arrow. Now the other thing we need to know about the arrow is which way it's facing. We could add a variable for this. We actually don't need that. We can actually just check its angle. Now, for some weird reason, there's no actual method to check which way something's facing. Check if it's between angles. But what you have to do is go to System, Compare Two Variables, and just do arrow.angle instead. So if it's 0, it's facing upwards. That's basically its default position, means you've not rotated it. Before we do anything else, we're just going to add the action for this, and that way we can copy and paste the action as well. And just like before, we're just going to do player, simulate control, and we're going to move the player upwards. We can now copy and paste this 4 times. Each time changing the angle by 90 degrees and changing direction from up to right. On this next one, it's going to be changing from up to down now. And then obviously the final one is going to be the only direction that we've got left, being left. So that's our movement in place. Just like before though, we do need to do a couple of checks. So first one, we're just going to say if player is overlapping another object and the arrow, this time without checking the angle of any of the arrows that's overlapping. We're going to take the player, scroll down, and set default controls and turn them off. Copy and paste this, invert, and change it from false to true. Now if we test it, if we move over to any of the arrows, we're now stuck into the conveyor belt until we get to the end. It doesn't matter which part of the conveyor belt that we join. So, time to design the gym. Welcome to the normal gym. With this, you've got to use the correct conveyor belts to try and get to the end. However, as you can see, there are many conveyor belts that will send you right back to the start. This one has took me a bit of time to design. It's quite an interesting solution. Again, this is one that would be quite useful in lots and lots of different games. So have a play around with it, see what you can do, and try it out for yourself. Welcome to Gym 4. On Gym 4, we're going to have the ground gym. And if the player overlaps one of these crackable floors, then it's going to change the animation to this crack texture. If they then stand on that floor again, the level restarts. So this is a classic puzzle where you've got to step on every tile once and once only, and then get to the end as well. So first thing we need is a sprite with two animations, one normal, one cracked. And you could do this with ice. I already used ice, so I thought I'd mix it up and go for ground. Next, we need to add our first instance variable. So we're just going to edit instance variables, add a new one, and we're going to call it visited, and set the boolean. And by default, it will be false. Next, we go in. First thing we want is a system variable. Scroll down, and we want this for each. And we want to check for each crackable floor. We're then going to add in a blank sub-event. I'm just going to check if the player is overlapping another object, and it's going to be our cracked floor. Next, we're going to add another sub-event, and there is a reason we're doing all these sub-events. Mine is under Gym 4, but it's just the crackable floor. I'm just going to check if it's playing animation 1. Now, animation 1 is the one that isn't cracked. We also just want to add another condition, Gym 4 again, scroll down, and we've got this option, is boolean set. And we want to check this visited, and we're just going to invert this. Now, all this does is make sure that we leave the area of the first tile before we do this check again. Without this boolean, what would happen is the floor would crack and break straight away. So we just need that one boolean to check all that. So we're going to add an action now. Back to our Gym 4 crackable floor. And now we're going to set the animation to animation 2. We also need to set the value of this boolean. So just scroll down, set boolean. Now it's visited. We can set that to true. We're then going to right click and add an else statement. We're also going to take this is visited, copy and paste it onto our else as well. And now this is the time that we've stepped on it. It's now playing animation 2 instead. So you could change this, say animation 2 if that's easier for you in terms of code wise. I've gone really lazy by putting the else there. And this time we can just do system, scroll down and restart layout. Now this code at the moment checks if we visited a tile and set it to true, so we have to leave it before we can set that back to false. So the moment that we're not overlapping it, we're just going to right click, add an else, go back to Gym 4, back to our crackable floor. And we're just going to set that boolean this time back to false. And that is gym number 4 done. So if we run this to test it, if we walk over, it starts to crack. If we go over any of the cracks again, we restart from the beginning. So the aim of the puzzle would be to go to all the different squares and then get to the end without stepping on a repeat. Time to make our gym room. Before I show my gym off, I should actually add one more feature to this. And we only want the end to appear once all the floor tiles have been cracked. Now, obviously you don't need to include this feature if you just want to make it so you can step on it once and then that's it. You can get to the end however you want. But in the original Pokemon game, it is a case you need to step on all of them to unlock the end. So let's put this in now quick. Going to add an event, going to do system, and what we're going to do is we're going to scroll down to this option that says pick by comparison. And what we want to do is we want to pick any instance of cracked floor where cracked floor dot animation name equals, and we'll do the equals under here, sorry, and then animation 1. Again, just check your animation names, so go through animation 1 or animation 2, sorry for that one, that's why we check it. And then we're going to use this other action, which I've just found out about, which is very, very useful, which is cracked floor dot pix count. This tells me how many instances of cracked floor have animation 2 currently on. And all we're going to do is check if it is the same as cracked floor dot count. If those two line up, then we can take our end, and all I'm going to do for this example is just set it to be visible. So I'm just going to take my end, and by default I'm going to make it initially invisible off. Let's have a look at my gym. So welcome to the ground type gym. For this puzzle you need to step on every single tile at least once, and then still be able to get to the end. Now this is very, very challenging. As you can see, I've already made a mistake that means I cannot solve this puzzle. I don't know if this one's actually solvable. It is based off a real Pokemon puzzle, but my dimensions are slightly different, which might be enough to make it unsolvable. You try it yourself, see if you can solve it, because if you step on the cracked floor twice, you're back to the beginning. Next we move to Gym 5, which not only is really annoying in the games, it was just really annoying to program as well, and this is teleporters. You have teleporters on the ground, you step in them, they take you to another random teleporter, and you've got to try and figure out the pattern to get to the end. So how do we get started? Well, first thing I've got is just a teleporter sprite that I've created already, so you can create whatever sprite that you want. And the next thing we need is to add some instance variables. This is probably the most variables that we'll need out of all of the gym puzzles. So the first thing that we need is we need something called a channel. Now I'm going to use this as a number, you can use this as a string, but essentially it's a way that we can link two teleports together. So for instance, if two teleporters on channel 0, if you step through one, you'll come out the other side. If two teleporters on channel 1, you go through one, you'd come out the other side for that as well. So we'll set this to channel. The other thing that we need, and this is very much to do with tile-based movement, is a variable to check if we've re-entered the space. So re-entered, and we'll just set that to false. So let's move on to the code. First thing we need to do is add a global variable. So if a player overlaps a teleporter, we can save the channel of that teleporter and then look for another teleporter on that same channel. Next, we're going to add an event. Now, we're not going to check if the players actually overlapping the teleporter. We're going to do something slightly different on this one. We're going to do teleporter, scroll down, and compare X, and see if it's equal to players X. Now, because we're using tile-based movement, this happens very, very often. If you step in the same square, you've got the same X coordinate. If you've got 8 directions, trying to get this to match up can be quite difficult because you could be a point off, but really easy to do with tile movement. And we'll do the same for the Y direction as well, so just right click and add another condition. The reason that we're doing this, not just check if it's overlapping, which is far easier, is it means that you have to be exactly on top of the middle of the teleporter instead of just overlapping the edge. And this makes more sense. You get in the middle of the teleport, you get teleported instead of your foot touching the edge of it. We also just need to add one more variable, and this is just going to do a Boolean check, and we're just going to see if re-entered equals false. If we don't do this, what's going to happen is we're going to teleport back and forth really, really quickly between two spaces, which is really, really annoying. So by having this variable here, we can check, have you just teleported? If so, don't allow them to teleport again until they've stepped off the tile and stepped back onto it. So if you are standing on a teleporter, we're going to add an action. We're going to go to system. We're going to set the value of that channel variable, the global variable, to be the current teleporter that we're standing on. Next, we're going to add in a blank sub-event. And what we want to do is we want to find the other teleport that links up to this one. So under the system, we want to use an option called pick all. Now what this will do is this will pick all teleporters once again. So there's my teleporter, because currently we filtered it down to just the teleporter that the player's on. So it just allows us to repick all teleporters once again and reset those conditions. Now we also don't want to include the teleporter that we're currently standing on. So what we're going to do is we're going to do teleporter is overlapping another object and select our player. And then we'll just invert that. So press the invert. So now we're picking all teleporters that the player is not overlapping. And then the final thing is we're going to make use of that channel. So we're going to go to compare instance variable, where channel is equal to channel with the globe icon. So again, now if we stand on teleporter, we're going to find another teleporter that we're not standing on that matches the same channel. So what we can do now is we can take our player, set position, and we're going to do teleporter.x, teleporter.y. Now, one condition that we shouldn't need, but I find we get some weird errors if we don't include it, is we're going to scroll down to the tile positions, and we've got this set grid position. And what we're going to do is we're going to do player dot tile movement dot grid x, and then do the same for grid y. If you don't include this, what seems to happen is sometimes when you come out the teleporter, you'll take a step in a random direction. So I'm not sure what this is, but we'll set that to instant. And again, this bit of code seems to fix it, and I don't have any more issues, so I like to put that in. And then finally, we're just going to go to our teleporter once again, scroll down, and set the boolean of re-entered to true. This means we can't teleport back from the same teleporter anymore. And then the final bit of code, just to finish this all off, is we're just going to go back to teleporter, is overlapping another object, being our player. Invert this once again. So if you're not overlapping a teleporter, then we can take our teleporter and we can now allow it to be re-entered once again. So re-entered, now false. And that's probably the most confusing code of this video. Before we test it, there is one final thing we should do, and that's actually set our channels. So you see that this teleporter is currently set to channel 0. This one's set to channel 0. This one I'm going to set to channel 1. And then this one at the bottom I'm going to set to channel 1. And let's go for our test. So now if we step into this one, we come out at the bottom. If we step into this one, we come at the top. And again, we can step into these in any order. We'll always go to the one that has the same matching channel. Let's build gym number 5. Welcome to the Psychic Gym. In this puzzle, you need to step on the different teleporters to try and find your way to the green square. However, each time you're going to get teleported, so it's up to you to try and find which pattern will get you to the final end square. This one's really silly, quite fun. You can do quite a lot with teleporters. Again, it just allows the player to sort of go around and they can start building a little bit of strategy of where they need to go. Eventually they'll get to the end. It is a little bit random, it feels like, but you are going to the same place each time, so you can start learning where to go. But you could use it in any tile-based game for just general movement from level to level. Now, it wouldn't be a Pokemon game without a rock puzzle. If you're not sure what these rock puzzles are, essentially there is a boulder that we can push around the screen, and we use that to try and solve some sort of puzzle by rearranging the boulders. So how do we approach this? First thing you need a rock sprite. So I made mine a bit smaller, so my grid size is 64 by 64, this is 48 by 48, so I made it a bit smaller. It does not matter, you can keep it the same size, but we'll show you how to get this to work. So we'll start off with behaviors, because we do need some behaviors onto our rock. The first one we want is solid, so we can't actually move for our rock. That's really important because we want to rearrange the rocks in a way that we can make a path for us to get through. And if we can climb over the rocks, then there's no point in doing that. And the second one to add is the tile movement, because our rocks are actually going to follow the same rules that we do. It's going to move in a grid format. Now, we're going to try and edit this to match our player. So our grid width is 64 by 64. I've got an offset of 32 by 32. This just means that our object's placed in the center of the grid, not on the corners or the edges. And then the speed, my player's got 200 by 200 speed. Okay, doesn't matter if your rock moves slightly slower than your player, it's absolutely fine, but we do want it in the same grid rules as your player. And if you're not sure, just click on your player and you can see all the different tile movement rules that you've put in place. Going into our event sheet then, we've got one event that we just need to repeat 4 times for our 4 different directions. So once you get this down once, it's actually really easy to do. So we're going to do if player and is overlapping at offset. So what this means is this is going to move the player's hitbox down, do the check, and then if it's true, we can trigger some code. So we're going to do our rock, and we'll start by going down first. So our offset's going to be 32, so plus 32. So is the player overlapping the rock? Next, going to add a condition. We're going to do our rock once again. Scroll down to the tile movement, and then can move in direction, and the direction is going to be down. Now distance is how many tiles. We just want to check if it can move down 1 tile. And then our final thing we want to check is just our keyboard, and have we pressed the key down. Simple as that. Now, if all of those rules are true, so we're next to the rock, we've pressed down, and the rock can move down, well, simply put, we're going to move the rock down. So we're going to go down to the tile movement, simulate control, and move down. Now, one thing I've just remembered that I've forgotten about is just on your rock, if you click on it, we do want to make sure default controls are off. If not, when you use the arrow keys, the rock's going to move by itself. So just make sure this is off as well. But once you've done this, that's it. You've got all the code that you need. The only thing you need to do is repeat this for the 4 directions. So instead of down, we'll do up this time. And instead of the offset being 32, we're going to do minus 32. Instead of checking if we can move down, we want to check if we can move up. And instead of moving actually down, we're actually going to move up. Same goes for the other directions. So we'll start with right first. So are we pressing the right key? For the offset, the Y is now going to change to 0, and the offset for X is going to be 32. And can move down will obviously be right. And if all of that's true, we're going to simulate moving right. And then once again for left. So left arrow. Offset, as you can guess, is now going to be minus 32 on the X and 0 on the Y. And then we can press left and then left. So lots of fiddly changing around, but again, you need to set this up once. So let's do a test. So I've got my rock. I can press down to move it. I can move myself back into position. I can move it across the screen. It will get stuck if it gets again. It will get stuck if it goes against the wall. So if I move this all the way down, I've got no way to move it back up. So you do need to be careful if you're going to move it against the wall. And if you move it to a corner, it's completely stuck. Again, this mimics Pokemon games and a lot of puzzles you'd see around this. We have got a way that we can move this rock around the screen. So let's make gym number 6. So here we have gym number 6, the rock gym. Again, this is a classic puzzle where it's up to you how to move these rocks around to try and get to the end. Not a very difficult solution, but you can get very tricky with this to make this much harder. But again, the idea of just pushing boxes around is a puzzle concept that's around in so many different games. It's a great one to add to any tile-based game. Welcome to Gym 7. For Gym 7, what we're going to do is we're going to have these objects here and a button. And when we press on the button, these objects are going to spin 90 degrees. Now these will be solid objects, so we won't be able to go through them. So there's more issues with the creation of the sprites than actually with the code. The code's really simple on this. There's a couple of tricky bits when it comes to creating the sprites. So let's have a look at that now. So I've got 2 animations. This is the first one, and this is my second one. And the most important bit is the image point. You see this one's set in the middle like normal, which means the object will rotate round the center. For this one though, I put it here because I want it to rotate round this actual edge. So I'm going to create a new shape, and let's have a look at how we can set this up. So create a new animation, I want to resize it. I need to do some maths now to get this working. So my grid size is 64. I need to work out how big I want this to be width-wise. So I want it to be 3 squares wide, so I need to do 64 times 3, which I believe should be 192. So I've got sort of the width sorted now. In terms of the height, I want it to be 2 tiles, so 128, again 64 times 2. And then I'm going to press OK. Now what I also recommend is adding on a grid. Now I've configured my grid to be 64 by 64, being the size of my tiles, and snap to edges. Now what I can do is I can come in with a square tool. I'm going to just select the grey colour that I've been using beforehand, and I can fill in the squares that I want to do. Okay, so that is my shape that I've come up with, and then obviously you can go around and tidy it up to make it look like the other pieces. Once we've got this, we can then select our image point and we can decide where we want this piece to rotate around. So I'm going to select the obvious one being down here. Now let me turn off my grid first. I can just click anywhere, but we want it to match out of our grid so it's a bit more precise. So again, what we need to do is take a bit of calculation now. So my first square is 64. So I want to add 64, and then this is halfway through my second one. So I want to add 64 plus 32, which means it's going to be 96 across. In terms of the Y, I'm starting from the top again. So it's 64 plus half a square, giving me 96. So that's the difficult bit, is creating these animations and deciding whereabouts you want the image point to be. Again, the image point is where the image is going to rotate around. Final thing you need to do is just go to your hitbox and actually change this to match the new size. Again, you can make use of knowing how big the squares are, so it's just 64 here. we can then add a new point here. So again, we're going across 64 and down 64. It's a little bit fiddly, it takes some time, but once these are set up, you can just switch between these animations to get obviously the different size shapes that you want. So that's our first step. We can also add in our behaviors. So I'm just going to add behavior, starting off with the obvious one being solid. I don't want to be able to go through these objects. That's going to add to the puzzle element of this. And then I'm also going to add a second behavior. I'm going to add the tween behavior so we can have a little animation when it rotates. Our button doesn't need to do anything. It just needs to be something that our player can overlap. So now we can go to the event sheet and we can do a check to say if player is overlapping another object being our button. You can do the same thing with the teleporter where you can take the buttons X and Y and check if the player's X and Y matches it. If you want to make sure you have to be completely over the button for it to happen, but I think overlapping is fine. Now we've checked to overlapping the button, we just want this to trigger once so it doesn't keep rotating the objects while we're standing on the button, so we have to get off the button and stand back on it if we want to re-rotate. And then we can add an action, or in Gym 7, our spinner, and we're going to take our tween behavior, so tween one property, and tag doesn't really matter, we're just going to take the angle, and what we want the end angle to be is we want it to be spinner dot current angle plus 90. If you want to go the opposite direction, then you'd minus 90, so you could have one button to go clockwise, one button to go anti-clockwise. And then the time, I like to keep this quite small. You do have a bit of a challenge if you make the timer too long that the player could re-stand on it and re-trigger it again, and you might end up with some weird angles. But again, 0.2, 0.5 is probably fine. Again, it takes quite a while for the tile movement to move anyway. Let's go 0.3. That's it. That's all we need to do for this one. It's a really, really simple bit of code. So I'm just going to go in for a test, press it, and the arena changes. Now, one thing you might notice is my player moves slightly there. Obviously, if you're moving it and the player's in the way, that's going to cause some weird interactions. Just make sure your buttons are out of the way. But again, this is a solid object. I can't go through it. So again, this now becomes a bit of a puzzle of how I want this to move and look about. Welcome to the steel gym. Now, if you try and just run into this gym, you're going to notice the big problem being this doorway you can't get past. So if you first go to the switch and try and move the switch, it rotates all the pieces, but you have to rotate it a couple of times to get it into the position where you can actually start to get into the next area, and then you press the button once again to get to the end. I admit this is probably one of my worst puzzles that I've shown in this video. I was really struggling to come up with a really clever concept for this, but you'll come up with something much better than I will. Let's move on to the final gym. Our final gym puzzle is going to be the electric gym. What we've got is we've got a blue gate and a green gate and then two buttons. The idea is that one of these gates will be on at any one time. So let's say the blue gate is on and we can't go through it, but we can go through the green gate. And then if we step on the green button, the gates will flip over. So the green gate's now on, but we can go through the blue gate instead. You'll see this better as we put it together. So we're going to start with the animations because it's probably the most time-consuming part of all of this. It's not a very difficult step, but it's a bit time-consuming. So I've got an animation just showing an electric fence sort of pattern. Again, you don't need to go this far. But the main thing is I've called the animation on to say that the gate is on, and then the color. So in this case, on and then blue. I've also got the same for green, so on green, and then I've got off. And they're my three different animations. Now, you can add more colors for this, obviously. I've just kept it really simple with blue and green. Next thing we need to do with our gate is we're going to add an instance variable, and we're going to add one called color. This is going to be a string, and initial value will change for each one. So we're not creating a value initially, we'll have to manually just go and change it. So we just add these in now. For the blue gates, I'm going to call it blue, capital B to match what I did for the animation name. And then for this one, it's going to be green. Final thing we need to do from the gate point of view is just add the behavior of solid. This means if the gate is on, we can't go through it. And then the other thing you've noticed that we've got is these buttons. So I've called them button gate, not to be confused with my buttons I've used elsewhere in today's video. But we've got one called green and one called blue. And these names are really important because we're going to use the animation name instead of creating another instance variable for the sake of it. So when we're trying to refer to which button's which, we'll just take the animation name. So that's it from the sprite side. Again, probably the most fiddliest of some of the sprites that we've looked at today. Code-wise, not too bad, so let's have a look at it. So first we need is a global variable to keep track of which gate is on. So we're just going to call it gate on. This is going to be a string as well. And we'll put blue on as our first initial value. We only need 3 events to get this working. So the first one we're going to do is we're just going to go to our gates. I'm going to scroll down and compare instance variable. And we're just going to say if the color is equal to gate on. Just like so. We're going to do 2 things. So first thing we're going to do is we're going to set the animation. Now, we don't know if we're referring to blue or green, but there's a clever trick that we can do to get either animation. So we're going to write on, put an and sign, and then gate on. So because the blue gate's on, we'll use the animation on blue. If the green gate's on, we'll use the animation on green. So that just saves us having to do lots of checks to go, oh, if the gate's on and it's blue, if the gate's on and it's green. If the gate's on, we do want to add the solid behavior. So we're just going to scroll down till we see solid and just set enable to be true. And then we just need to copy and paste this code. We're going to add an invert to this one here. And instead of setting the animation to on and then gate on, we can just set this now to off. And instead of the solid behavior being enabled, we're just going to disable it. So that is it for most of it, but we've still got our buttons to deal with, and we just need one more event for that. So we're just going to say if our player is overlapping one of our buttons, then we can add an action, and we want to change which gate is on. So we're just going to set the value to gate on. And again, to save us having to do a separate instance variable, we're just going to use the animation name. So if we step on the green button, the gate on will now be green. Because the green gate's on, we're going to set that to solid. I'm going to change the animation from off to on. And then for the blue one, it now turns off and we disable the solid behavior. In practice, this is what it looks like. So the green gate's on, I can't go through it, but I can now go through the blue gate. And if I step on the blue button, the blue gate goes on and I can no longer go for the blue gate, but I can now go for the green gate. Let's make one final gym together. Welcome to our final gym, being the electric gym. You are trying to get to the bottom right. My end icon that I've used for all of these ones is being a green square, and then my buttons are obviously green as well, so that doesn't help. But again, if we try and tackle this problem, and we come over to this button first to allow us to get through the blue gates, we're now stuck here and we can't get back. And you can see there's a bit of a reset here that resets it, and we're back to the start again. What we actually need to do is ignore that first button, go around. We can now get this button instead, and we can loop our way back to the end. Again, not the most exciting puzzle in the world, but just gives you an idea of what you can start doing, and you can combine this into a much bigger maze where the user maybe can't see all parts of the maze. So again, pressing the buttons then becomes a bit more of a challenge, and if you add in a third color, again, that adds a lot more challenge to the problem. Well, that is it for today. Hopefully you've enjoyed this Patreon episode, something a little bit different. I've had great fun coming up with these. And again, it just gives you some different tile-based puzzles that you can put into any tile-based game. Thanks for watching, and I'll see you in the next video.